So hello everyone. Today I'm going to talk about how to do simple text editing with the Win32 API, and I'm going to go over these points here, like what we require, basically only Visual Studio, C++, and the Windows SDK. Then how to set up a command prompt because we're going to do everything in the command line, and then we're going to slowly get to the point where how to get the information about how to receive character from inputs from the keyboard and how to handle these. So without further ado, I'm just going to start. So first things first, if you have a Visual Studio installer and you want to know what kind of packages you need, basically you need almost none. Yeah, Visual Studio, genau. I'm going to do an update right now. That would be great for everyone, right? So basically, all you need to do is to click on the desktop development with C++ feature, and then you can then you get here a more detailed list of what to install. And you actually only need the MSVC toolchain, which is currently the version 142, and it's just the compiler and some libraries. On top of that, you need the latest Windows SDK, and you can kind of ignore anything else. You always need the C++ core features, and this is just for DirectX debugging. After you set this up, you can click on install, and it will take forever to install, like roughly about 6 GB of data. I'm not going to do that because I already did this. So yeah, it's in German. And this is probably all you need. So the minimal setup just to be able to use Visual Studio C++. After that, you have access to the native command lines. If you go to your start and type in native, it should bring up a search for the native tools commands. In our case, this 64-bit compiler. And if you click on go to location, you will find a list of these. Basically, what this is that you can compile for different, let me just dial down the sound a little bit. Basically, what this is, you can compile for different operating systems. Like, if you're on 64-bit, you can compile on 32-bit. We are on 64-bit machines, and we want to compile for 64 bits. And then you can basically just copy this. It's just a link to the command file. You can just copy this. Go to your project wherever you want it. I created a tutorials project like this. Paste it in there, and then you can look at the properties. And this is basically what's going to be executed. It's just a setup batch file that sets up Visual Studio and all the requirements so that you can... Wait a second, I got a message from Cakes. He can't find me. I don't know how he can't find me. Everyone else found me. Can somebody please send to Discord something how to get to my stream to Cakes? That would be great. Oh, he's here. Hi Cakes, welcome to the chat. I've just basically just started, so I will continue now. Okay. So basically this just tells the compiler to be set up properly so that we can use it in the command line. And other than that, we also wanted to start at a specific position so that we do not end up in this default position, but rather in where it's convenient for our project. So like this here. Just going to paste this in, and then whenever we execute this link, we will be initializing Visual Studio and end up in this text edit subdirectory. So with this all set up, you can just double click it and move it to some place convenient, and then you have access to the CL, which is the compile linker, the compiler from Microsoft Visual Studio. And this one will of course complain because we have no data yet. Okay, so this is the basic setup, and this is all you actually need. Okay, right now we're gonna start actual programming. So for that, I'm gonna start my editor, and I'm gonna add a main CPP file. just for some sanity checks, I always like to start with the main file and print hello world to see if my toolchain is actually working. Sorry guys, because I'm not going to be looking at chat for the most part, but afterwards when we have the Q&A we can talk about all the things that I did. So, like, this is the basic setup for main, and then you can compile it on your in the command prompt like so. You just type in CL for the compiler, and then you mention which file you want to compile. In our case it's the main CPP, and then it will complain because it doesn't know where to find printf, which is completely fine. Printf is located in stdio lib h, I mean. Then we recompile, and now we have a working program. Assumedly we can look at the folder and see, oh, there is some main exe, and then we can try to execute it, and we see here it printed hello world. So everything is set up properly. Sometimes you don't even get to this point, and then you have to fix your whole environment first. So it's always good for me to know that everything works when I start off a new project from scratch. So now it's a little bit inconvenient to type the whole command all the time, even though we have a history. We want to put that into a file so that we can basically just call the batch file. So I'm gonna create a build.batch, and I'm just gonna type in what we have there. So it's cl main cpp, and that's it. And then we can just call build instead. It works the same way. Another thing that's a little bit ugly is we are kind of spamming the whole folder with all these files, and there's no structure to it whatsoever. Also, I forgot to mention that I actually wanted to make a subfolder. So let me do that first. I'm going to make a subfolder called text edit day 1. Go to that. I'm going to manually move the main CPP over there and the build. So then reopen my editor at that location, and then we have the build. And if we compile now, we should have the same situation. Now everything is here, and we can delete all this stuff except for my to-do and how to open the command prompt. So now we want to clean up this code a little bit. I personally like to place my code inside a code directory, and my compilation stuff into a build directory, like so. So I would move the code, the main CPP in the code file, and delete these exes and compilation files. And now we want the compiler, the build script to spit out all this information in the build file. In order to do so, we have to use the command called pushd, which says, which tells the batch script that you want to move into a directory, and the directory is the build directory. And if you're done, you can call the command popd. Now everything will be generated as if we would have called it inside here. We save, and then we run the build batch, and now it will complain that it can't find the main CPP anymore because the main CPP is not in the build directory. So we have to give a relative path to that. I typically use something like source equals cd, which stands for current directory, and then you specify the full source, like so. And then we can use the source variable instead, like so. Oops. And now it should build everything into the build directory here. And for convenience, we want to copy the main exe outside so that we can access it here. So after we do the popd, we can do a copy and do a copy the build main exe to main exe. And this way we will all have a working copy right there in our main directory. And then we can just call main exe all the time to test it. So I think this is the easiest setup. So this is the minimal setup, and now we want to get more into the Windows part of things. For that we open our main CPP, And first things first is we include the windows.h. And we want to create the Windows main loop. So for that, we just have a loop variable which indicates when we stop the loop. I just call it doContinue. Set it to true, then while doContinue is true, we will keep going. And here we will use our first Windows API command called peak message. We can Google it. It's always a good idea to have the documentation available so that you can see the signature and some documentation. I'm just going to copy the signature, paste it in here, and wrap this around a while. And what it requires is us to fill out a message parameter, so we can create one on the stack, MSG message. Doesn't have to be initialized because peak message will override it if we pass it, like so. Then it wants a window, and it indicates that it's optional, so we can just pass null here. And then it has some filters, so maybe you can say what messages you want to receive and what to ignore. In our case, we want all of them, so we pass for min and max just 0. And the next one is what to do with the message after we looked at it. And you can find some options here, but we're going to remove it, so we specify pm remove, like so. And this is our main message loop, and we can print something here. For instance, for every message we get, we're just going to print hi, like so. And then we're going to try to compile this, and it should complain that it can't find peak message A, because peak message A is defined in Windows H, but it's implemented in a library that we have to compile against. If you scroll down the Windows functions, you will find which library it requires. It also tells you which header it requires. In this case, it says winuser.h. I don't know if you can read this, but it recommends to just include windows.h, which is what we do. Other than that, it says we should link against user32.lib, and that's what we're going to do. And in order to do so, we can go into our build patch, and we want to tell it to link against this library. In order to do so, we have to add the link parameter, which basically tells the compiler that everything after the link is an option for the linker. In our case, we want just to say, well, we also want to link against the user32lib. So all parameters before the link here will be passed to the internal compiler, and all after them will be passed to the linker. So in our case, it says it does not know about this file. Maybe I did the backslash wrong. Yeah, so the backslash is wrong. Now it found the library, it linked against it, and produced a proper exe. And now if we run it, we have hello, and we see no messages. We get no messages whatsoever. The thing is, we only really receive messages once we have a window. The other thing is, though, that this program is still running in infinite loop. So, for instance, yeah, we have to kill it here, and then it's gonna be gone. So I don't know if it was here somewhere. Let's just see. Do I have a main exe somewhere? Do I have a main? Maybe because it's part of a shell and we don't see it. Yeah, thank you. This is really useful. But believe me if I tell you that it's still running in the background, so you have to press Ctrl-C to kill it off. So, in order to get anything done, we need a window. So also we can print, if we have finished all the messages, we can do some code that concerns us, like for instance render a frame. I'm just going to call this frame and see if this at least prints something. Yeah, you can see it's running infinitely, so it's doing something, but it's useless. So with Ctrl-C, we kill the process, and now we are up to the task to create a window so that we can actually receive some messages and display stuff, because this is a Windows GUI application. At least that's what's going to be at the end. For that, there is the function create window x. The create window x function will give us a window handle that we need for other operations too. So at the beginning, before entering the loop, we can just create a window, and that window will then be able to receive messages, and we can poll those messages and react to them. So first things first, we have different options like the DVX style. I think we can ignore that. This is only some special styling about how the window would look. Then we have a class name. This is something we don't have yet, so I'm going to leave this open. Then we have a window name, which is the title that's going to be displayed. We are very confident, so we're going to call it text editor. And then we have the normal DV style, which is what the create window without the X version would take. And this is where we specify the basic appearance of the window. Oh, black window. It's black window. What happened? Why is this a black window? OBS, why did you do this to me? Don't touch these. We're back, I think.
Yep.
How much did I how much did I miss? Okay, I was about to use the create window X function. Yeah. So how much did you guys miss? Okay, let's go, I guess. So I'm just going to repeat it. So we will create a window with the Windows X functions, and the first parameter is a special style that we ignore. The second parameter we will set on later. It's a window class. It's basically, you can have different classes of windows which supposedly should all behave the same. And your window would be an instance of that class. Yeah, pushdoy, there are objects even in the C API of Windows. And then there is the title. And the next thing we want to set is the style. So this is how the window appears. So the style, you can look at the different styling options here. And we are only interested in the default style, which is a VS overlap window. Just specify this. Then you have the X and Y coordinates, so you can basically decide where to place the window. For instance, if you close, like in this editor, for instance, if I Alt F4 and then I reopen it, I kind of store where the windows are positioned, and with that parameters you can basically recreate the position on the time when you closed it. We're not gonna get into that though. Just so you know, and if you don't care, there is a special keyword for that. It's called CV use default, and that's what we're going to specify for the X and the Y coordinate. Then we have a width and a height, and the width and the height basically also includes the frame and the title and everything else. So if you wanted to specify a width only for the region inside the window that you care to render, you have to do some extra work, and we're gonna skip on that also for now. Then we have a parent window. In our case, we don't have parents, we don't have a menu. And then you have the H instance. This is something we want. Just gonna name it, and we will get it in a moment. And then we have a parameter, which is basically a value we can specify that the window will receive on its creation. So you can pass in some weird stuff here and do something on creation then. The return type is WND, which stands for window handle, and I'm just going to call it window handle, like so. And as you can see, we have still two unknowns, which is the window class and the instance. The instance is the easier thing. We can just, it's from type H instance. And we can get it by calling get, we always Google, so get module handle. And this will give us the instance if we specify 0. Returns the handle to the file used to create the calling process. This is what we want. And yeah, that's all there is. And as you can see here, it returns an H module instead of an H instance, but we will just cast it because it's essentially the same. Oh, I didn't copy. So we just pass 0, it's just pass null and cast it to H instance, like so. Then we have a Win32 instance. It's sometimes required for some operations on Windows, so to pass it. It basically represents your application in some form, I think. I don't really try to think about the reasoning. I'm just gonna use it as Windows wants it. And now the next thing is this class name. So we can just type an arbitrary name like my text editor window class, but it's not gonna do anything. So we can just test this and say if window handle. If we don't get a window handle, like so, so if you look at create window, it tells you that on failure it will return null. So we can check against null and print something like could not create window, and then just abort mission. Everything is lost. Then we recompile and build again, and it tells us that it couldn't create the window and aborts immediately. Also, another thing we might want to do is you can see there's a whole lot of spam every time we recompile, and we actually only are concerned with errors. So we might want to fix that. So a little sidetrack here. In order to fix that, we can specify some more options to CL. For instance, no logo, which basically removes the Microsoft license copyright nonsense. That's one step. Okay, another step is to basically, you can see that when calling build, every line in your build file is being also printed out here. In order to avoid that, we can set the echo to off, like so. And now we will only receive certain messages, like CL will still give us some messages. That's something that we cannot turn off, and copy will also give us some messages. But we also want CL to give us some messages like the errors and warnings. But we don't want the copy to tell us every time that it copied successfully. So in order to ignore that, we can use the pipe commands and redirect the output to null, N-U-L, not L-L. And that will basically move whatever copy would have printed to nothing. And now you see the only message we get left is just the source we have and if there were some errors, which is pretty clean, and I like that. So now we can still call main exe as before. We could not create a window. Okay, so back to creating the window properly. Yeah, what was missing is this. It cannot be just an arbitrary piece of text. In order to successfully create a window, we actually have to register window class first. And you will also find this in the documentation, I think. Here, you know, it recommends you to use register class, and that's what we're going to do. So before we create the window, set register class, and it requires a wind class as a parameter that we have to fill out. I'm just going to initialize it to 0, then pass it to wind class, to register class, and then we can basically just, if you look at how the struct is built up, then we can just use the name that we registered it with to pass to the create window function. Well, first of all, we want to specify a name. So you can use whatever name you want, like this, for instance. And then you can just pass this whole thing back here so that you don't have to sync these up. So basically, this will never change. So you can just reuse it. And now this, it's not all you need. You also need the instance here again. So, which is weird because you're passing the instance here in create window, but you also need to pass it to register class. So I guess it's Windows API, everyone. So we're not going to question this because at some point it really doesn't make any sense. And the other important thing that we need is a window procedure, which is a callback that is going to be called whenever we receive some messages, like when you want to resize the window and something. So there are some more things that you can pass here, but this is the bare minimal to make it work, I think. And we can look at what window proc is, and it should tell us about the default window proc near this one, def window proc. This is basically the default handle, default callback. We can just use that if we don't have our own, but we'll be going to replace this later on, just so we get a window finally. So we recompile, we run, and we have our infinite loop again. So this piece of code didn't trigger, but as you can see, there is no window nowhere to be seen. Pretty bad. Simple fix though, we can just use show window. Another user yesterday mentioned how horrible the naming in the Windows API is, but for the most part those names are pretty straightforward, except for accessing fields and stuff like this. But the function names are more or less clear, even though they always have way too many parameters, and most of them which can just be ignored. So in our case, the show window function wants to know which window to show in our the window handle, and it wants to know how to show it and what kind of style, like is it maximized or anything. So you can read up in how you want to initial pop up to be, and we're just gonna use the default one, like so. It's always good to wrap around these functions to see if something has failed, but I'm not going to do it right now. So, wow, we have a window, and it's called text editor, and as you can see, we cannot even drag it. Isn't that awesome? Why can't we do anything with it? Oh boy. But you see, we also get messages. Our while loop now is being called because we receive messages. We just don't do anything about them, and that's why our window is kind of frozen in time. So the minimum things that you need to do in order to make the proper loop is to use translate message on the message you received, and then also a dispatch message on the message you received, and that should do the trick to enable default behavior in Windows. Let's see. Oh, we can drag, we can resize, hey, but it doesn't clean up anything. So this is now a basic working main loop for a Windows graphical application, and we can now get rid of the printf for now, and also get rid of the frame. And now the next step, I have to consult my notes because I don't know how far I got. So we were main loop window. Yeah, the next thing is basically the core of this whole tutorial is the vmchar message, which is the message that we receive on character input from the keyboard. So in order to do so, we have to switch on it, or we can switch on it. That's if you look at the message, there is a message in MSG, and this will tell you what kind of message it is. And in our case, we are interested in the vmchar message. So we can just say, in case it is a vmchar message, we just want to print for now. Like so, we print the code, and we might want to print the character if it is a character. So we can just oh yeah, in order to know what kind of how to interpret the message, you of course still want to Google it and look at the documentation, and it will tell you that the character code is being handled in the W param of the message. So if we just print that, like MSG B param, and also cast it to a char, assuming it is a one-letter message, we should be able to see it properly. So what is this? Build. Oh yeah, it complains. Yeah, because this W param is from a different type. We're just gonna cast it to int because it's essentially some kind of integer. So now, if you type in something like hello, you will see that these characters were produced, and we can handle them. them. Also, if you if you hold down Shift, you also have caps characters, or you have special characters. So you get basically all kinds of characters instead of just getting whatever the key hits. And this is the information that you need in order to build a text editor. So, so now we want to be able to just display some text and then manipulate it. So this is the basic idea. Okay. Next thing is we want to react to the paint event and render something to the screen. Right now our screen is just plain white, but we want to display some text and then show how we change it. For that we can use the VM paint event, which tells Windows when it requires your window to paint. This is old school API, by the way. I'm just going to use the GDI API from Windows, which is not recommended, but we can do easy text printing with it. Printing text would otherwise be very, very would have been a complete tutorial on its own, because you have to set up a proper renderer, then you have to load text files, and then you have to render text files and all this stuff. But the main focus of this tutorial is basically just to show how to manipulate text. And for that, we're just going to use whatever resources we have available to us without any other setup. This is basically just some placeholders. So just so you know, I would assume that you would replace this code with however you render your text. So in order to react properly to the VM paint message, there is a begin paint and an end paint and all this stuff. We're just gonna implement that. So use begin paint. I need some water. How's everybody doing so far? Am I too fast? Am I too slow? Yeah, I'm gonna do the SDF font rendering in Vulkan right now, right here on spot. Begin paint requires us to pass down the window handle, and it requires us to pass a paint structure. It will initialize this paint struct, and then we can do rendering. So we're just gonna call this paint. It doesn't matter. And it will return us a device context from type HDC. This device context basically in some form or another represents your rendering device, like your graphics card or whatever, some abstract form of that. We're not too concerned with that. We only try to appeal to the Windows API gods, so we just try to enforce the protocol and basically just use that. Again, this is just throwaway code. You will later replace this anyway. So, if when we're done with rendering, we should also call the end paint. So rendering is being done in some kind in this kind of scope. So, like between begin paint and end paint, and we pass the exact same things as in begin paint. Like so. We can check for errors, but I don't care right now. But you should, if you're using Windows API. And right here we can now render something like text. For instance, with the draw text GDI function. Oh, by the way, this already will not work. So, as usual, these functions are... Oh, it did work. I am surprised. Then this one probably should not work then. Okay. Draw text basically says it wants the device context to render to. Then it wants some text, like hello world. Then it wants to know how much text this actually is, so we can just we could manually count this, but that's of course stupid. So we will introduce an array count. I typically call it C array count. And we can pass static arrays to it and get the length of it. So I'm just going to type it down and then explain it a little bit. Like let's So basically what we do is we call size off on the static array, which gives us the whole byte count of the whole array. And then we call size off on one element of the array. So if we decide the whole, if we divide the whole array byte count by how much byte one element takes, we know how many elements we have. So that we can use this, and we can just say text equals, as a static array, equals hello world, and then we can just call, we can just pass text and see array count of text. And the other things that we need is a rectangle. I think this is optional. Is it optional? Oh no, it's not optional, so we will have to specify it. This is how it looks. It just basically tells you how big a region is, so we just call it rext again. And then you say stuff like left is the x position, basically. You say left 100. Top is the y position, and in Windows things are counted from the top to the bottom. So if we say from the top, it's 100 away, and then we can say, well, rect right is whatever rect left is, plus some spacing that we might want to consider where the text fits in. And the same goes for rect bottom. It's just rect top plus some space, and that should fit the whole text. Like so. Then we can pass this here as a pointer. And then we have some formatting information, which I do not know what that was. I think we can ignore this. Yeah, we just say it's left aligned. That should be enough. So basically, it will be left aligned relatively to the box, like so, and it returns a value which is basically how much it advanced in the y direction. We don't care for this right now. So, and now you can see that, oh, we have some syntax problems. 55, it says, I guess I have too many, or not enough. Oh, this one is too much. Yeah, so my macro was wrong. I had too many braces, parentheses. So now it compiles, but it tells me, why does it compile? It should be complaining that I should include the GEI lib. Now I'm really confused. Let's just see if this worked. Yeah, we have some text. So far so good. And now the next step is to make this text dynamic using our characters that we receive. So far so good. How good are we in time? 45 minutes. It's pretty good, I would say. So next thing is we want some dynamic text. And the easiest way to do so is just to have some buffer that we can write to, and we just remember how much we have written to it already. So so we will have a new variable here outside the loop, because it's going to be persistent between frames, basically. And because I don't like just having plain C-like strings, I want to create a struct that records where the string starts and how many bytes or characters there are, bytes in this case. And because I'm a maniac and I don't like the standard namings of these variables, I'm gonna rename them, and you can basically ignore the step if you like, but I personally always like to have cursor names. In order to do so, we just tell what type we want to rename. For instance, unsigned char is what we want to store binary data in, like what our string takes, and we want to rename this unsigned U8 for unsigned 8. So we can just say U8. Feel free to skip this step if you follow this tutorial. Another thing that we want to is unsigned int, which is the default 32-bit integer. We also might want to have the signed version of that. I always type signed wrong, so like so. And I call these typically S32 instead of a lot of people would call that I32. I don't get it because it's either signed or unsigned. In either case, it's an integer. So yeah, I'm calling it S32. And also for the count, I want an unsigned long int, which should be a 64-bit number, and I want to have an alias for this. So I'm gonna rename u64 into usize, which is basically for 64-bit programs is how the address, how many, basically how many bits the address of an object has, like a pointer or stuff. So this is what we're gonna use. It's not really necessary, you can just use int or whatever, but if you were ever to use it properly, you would do this and you would have no problem. So now we have our little string struct, and now we need a way to, just in order to see that this works fine, we want to now only use those kind of strings. And for that I will introduce a new macro I just call as. I expect a static string here, and I will generate one of these structs with a static string. So first thing I do is gonna use the static string address as the base, and then I will use the length of the string as the count. So no semicolon. So this way we can just do something like, instead of saying hello world like this and then calling carray count every time, we can just say string text equals s hello world, like so. And then we can just say text base. This function requires it to be a char pointer, so I'm going to cast it to char pointer. Even though they are literally the same thing in C and C++, char is neither signed nor unsigned. So if you define your type to be unsigned char, you cannot implicitly convert them, which is stupid. And this here requires it to be some kind of integer type, so probably won't handle any more than this. And we're just going to see if this still works. Yeah, it compiles, it prints exactly the same thing. And now we have a better way of talking about strings. The reason why I do this is because I can now essentially I could view sub pieces of the string by just saying something like string sub, and just say it's text, but it's base address starts 5 bytes in, and therefore also its count is 5 bytes less. Notice that the data itself is not going to change, just how we look into it. So, and now if I were to just print that instead, I'm just gonna reassign it to text, and then we should only see like world or something. Yeah, okay, you see? Of course you have to always check that your advancement is correct. But basically this is how I use strings. They don't store any memory in themselves. They are kind of like in a view into some memory. And you can adjust this without copying anything. You can just say, well, I want to just look at some subportion of that string. And I find that very powerful. And also you basically always want to specify how big the string is alongside with the memory location. And so that it's a good idea to bundle these together. Pushtoy would call this a builder, I think, maybe. But it's just an array implementation with an explicit count instead of relying on zero-terminated strings. I need to drink another one. So now we want to create a buffer that holds all our all our potential text. Also outside the main loop, I'm just gonna say U8 text buffer and make it big, like 1024 bytes. And then I'm gonna have a text string that looks into that buffer. And essentially what we do is we just say, well, the text, I can do it explicitly if you want. The text base is whatever the text buffer is. And the text count for now is just 0 because we haven't placed any characters into it right now. So, and with this information we can now start to enter characters into text and display it. But before we do that, we just want to display text. So we just delete our previous text and it should now use this one because there is no local variable text anymore. It will try to print this one instead. And we should see nothing. Very disappointing, but this is how it is sometimes. So since our text starts empty initially, we don't see anything. Now we want to add stuff to the text depending on what characters we type. And this is basically the other part, how to use this information. Now you can imagine that I can just write the handling and how to manipulate the text right here after the VM-char message. But I'm not going to do that. Instead, I will record whatever chars were produced and then use them here, because this is kind of like a per frame call function that you might have in a more complicated renderer, and all the rest of the code is platform dependent code. So you want your platform just to collect some information, and then when you enter your frame to render and update your game or stuff, you want to iterate over this information and do whatever you want. So you have a better decoupling between your platform layer and your usage code or your engine or game code or whatnot. So in order to do so, I will introduce a new struct, and I'll call this platform character. And all I'm gonna record for now is the character code. But you can imagine that you might want to have some more information, like whether or not some certain keys were held, like control or shift or whatnot. But right now we're just going to do this. So, okay. And then before we enter the loop, we have some platform variables, like I'm just going to call it platform characters, which is a buffer of, let's say, 32 characters. So this assumes that you are not going to type more than 32 characters in between 2 frames, which might not be the case if your application lags a lot. But if your application lags a lot, you probably don't really care if it works properly, or you probably wouldn't assume that it works properly at that moment anyway. So we're not going to optimize for that case. Then I want a platform character count, which tells us how many characters we actually filled in between frames. And all I do in the VM-char message is to record these. So I say if my character count is less than the array count of my characters. Feel free, by the way, to rename these things however you like. Then we can get a new character from this array, like so. Increment the character count also, and we take a pointer to that because we want to change it. So all we do is set the character code to, as we previously learned, the message wparam, which is what stores the character count, the character code. So now you have all this information, and just to see that this works, in the wmpaint method, we will now just display all the characters we received from the platform layer. So before we paint, maybe we have a while, the for loop, and say character count, go over all the characters that were recorded, and we just do the same thing that we did here and just print them and see if we receive any parameters this way. The only difference is that we now say auto character equals platform characters. at position E. And yes, this is a copy, but since we do not ever gonna change this data, we just read from it, there's a good chance your optimizer will notice this and it will choose the proper way to access this without copying. So also the data is very, very small anyways, but just for to know this. Other people might use a const here or whatever, but I'm just gonna copy it, suggesting that this data is not going to be touched. This is just my preference. And then you can just say character code. And all I did is basically just separate these two steps. So the platform layer just collects information, and this is basically our frame. And here we handle the information, and here we would do rendering. It's like frame, this is update, and this is rendering. So now we'll see if we collect any characters, and if this even compiles. It's always also a good thing to check. So now you notice that I keep on typing and nothing really happens. And the reason for that is because the WM paint message is only being generated on certain events, like for instance if I resize this. So I don't, yeah. Oh no, it doesn't. Okay, so I have to do something else basically. Just to confirm that this message is not being called more than once. It will be called once, but not a second time. And we should see that in the output. You see, print is being called once, and no matter what I do, it's not being called another time. So it's not a continuous render right now. And I don't remember what exactly what's the proper way to do this is, but I'm just gonna hack it anyway. I'm gonna use the function called invalidate rect, which basically tells not invalidate, which basically tells Windows that a portion of your window is dirty and you should redraw it. As again, this is a very, very old API, and we will do this after we received and handled all messages. Then we have time to do our custom code, and we will just say invalidate the whole region of the window, which can be just null, I think. Can it? Yeah, null means it's the entire region. And then we can also specify whether or not we want the area to be cleaned, but as far as I can tell, it didn't do anything last time I tried, so we'll see. And now we should be able to call we should be able to receive the WM print message multiple times, because Windows noticed that it's been unclean, or it's been marked as dirty basically, and so it needs to be redrawn. Again, this is just basically honest. Now you see we print the F. So now if we type in characters, we receive them. And as you notice, it prints them out every time, which means we have forgotten to clear these. We have to reset the character count for next frame, because we're only interested in what characters have been entered between two frames. And now I can remove the printf and just run again, and now we say hello, and all the messages from the platform layer are now in one place, and we can react to it. And this is the place where we're going to do text editing. Yay, finally, only 1 hour. It's only 1 hour, right? Yeah, 1 hour, that's great. Actually, we're quite in time, if you ask me. So instead of just printing this, we will also react to it. So we would say something like switch on the character code, like so. And we have a default case, which is all kinds of characters that we assume are just letters. And in order to be sure that they are just letters, we're just gonna say the character code needs to be at least The space sign, if you look at the ASCII code, you will notice that at this point the actual characters start. All codes prior to that are basically some kind of control characters. And to be extra certain, we want the code to be less equal to 172 because Windows nowadays supports Unicode characters, and Unicode characters basically means that you have a 32-bit character, and you cannot really store this as a byte per character. You have to do more fancy stuff to implement, for instance, UTF-8 encoding. So basically, one character would translate into 1 to 4 bytes, and your strings have to be able to handle it. Your rendering has to be able to handle it. We flat out just say, well, every character that is basically a multi-byte character, we will just flat out ignore it in our processing right now. But just so you know. So what do we want to do? Well, basically, now we come back to our neat little text buffer here. We just want to append this character to the text. So in order to make this properly, we want to see if the text count is actually if we have enough space available in the text buffer so that it's safe to add something like text base at the position text count, and the increment text count would be just the character code. Flat out. It's just a normal ASCII character typically, or a Latin character. So we just kind of cast this to char, and now we should have the ability to add text. Wouldn't that be great? Imagine. So let's just see. Hello world. Hey, it's blinking, but we can write text. We just can't correct. Oh, it's not big enough because our region is too small to fit it. Doesn't matter. We just can't correct it. That's all I wanted to say. So now you see we can add characters, but of course, especially for a person like me who does a lot of typos, it's great to have a way to delete them also. In order to do that, we want to first recognize what code is the backspace character. So if you run the application again, since we print out every character we hit, if we press backspace, you will notice the character code 8 is being produced, and this is the backspace character. Similarly, if you press enter, the character code 13 is being produced, and if you react to that, we can add a new line. So let's do that. So case 8. All we need to do in this case is just basically reduce the text count, but only if we actually have a text count greater than 0. So this is backspace. Let's test that. Oops. Hello world. As you can see, it doesn't do it. Maybe I didn't compile properly. Let's see. Case 8. Oh, I incremented it. Ah, I'm stupid. So, of course, you have to reduce the text count if you use backspace. Everyone. So you can see that maybe it's a little bit noisy, but we can delete the characters, but right now they're always drawn on top of each other. Really bad, right? But we can clear all the text and then type in capital letters over it, for instance. In order to clean up this this mess, we can before we start writing the text, we can clear out the whole region. And in order to do so, we can just call get client rect from Windows. Get rect, and this will give us the client rect is basically the area of the window except the borders and the titles and everything. So we get that, we pass in our lovely window handle. Then we have a rect. I'm just going to call it viewport because it's basically the whole region. And then we can use a function called fillRect, not in Java. FillRect. That's the one. That's the one. And oops. So then we want to fill rect. This time we need the device context, as all the other rendering commands also do. We pass the rect that we want to use for the filling, and then it requires some brush. And there are some default brushes, so we can just use, for instance, this one. This should be like the background color or something, so we don't have to think too much about it. And this should clear up all the region before we start drawing, and should get also rid of the blinking, I think. Maybe not. So, hello. No, it didn't. Well, that's horrible, but at least we can now see the actual length of everything. I tested this once, and I don't know, it used to work, so I'm not quite sure why it's freaking out this much. So, yeah. But basically, this is the basic input, and now we want to also implement new lines. For instance, if we just press enter, we're still in the same line. In order to do that, we want to react on the character code 13. And the behavior is basically the same as with the default case. We just want to append a character. So what I will do is basically move this into its own function so that we can use it here and in the new line function. So basically, we're gonna add a new function called append, for instance, and it's gonna get the string text. It's gonna get max byte count, or I'm just gonna call it max count for consistency, and then it's gonna get a character. So like this, and basically all I have to do is to convert the text dot into a text arrow. And then I have to use max count instead of the carry count, and I have to use character, like so. And now I can use this append function where I use this more complicated branch here. So I'm just going to do append, point at the text, oops, see array count of text buffer. And this is going to be character code like previously. And the same can be done here, only that we don't use a character code. Instead, we're just going to print the new line character. These single quote notation is to specify single characters instead of a double quote notation, which is to specify whole strings. So if you're really crazy, you could do something like, this is a string and I want the first item of that, which is the same. It's stupid, but you can do it. So I'm missing a comma. And now we should be able to add new lines to our amazing text editor. Hello world. How is everybody doing? You see, that was easy, right? So this is basic setup that you need, and this is basically all I wanted to show, minus the flickering. But again, this is just using old APIs so that I don't have to do font loading, I don't have to do font rendering and all this stuff. The main focus was just basically to retrieve the proper information from Windows. and how to use that to manipulate a string. And you can use it anywhere you want if you know how to do this. You can use whatever kind of rendering you want and whatnot. So I use it to build this editor, for instance. It's quite complicated. There's a lot of more steps involved. But this here, this is the core of this. So I hope this was helpful, and I am basically done. Let's just check my to-do. Yeah, I haven't done show cursor and move cursor. Am I gonna do that? Because the rendering is so bad. I don't even know if we see that. I'm gonna talk to chat first and ask you guys. What do you think so far? I need more water. I'll be right back. Kanske vet inte det. Ja. Ja, det är das Hollow-Hosting ist ein bisschen gut geworden. Dann mach ich jetzt kurz Auflicht. Ja. Ja. Oh, so. The reason for flickering is basically I haven't set up anything to avoid it. There's no real double buffering and anything, and I'm just... Oh yeah, now I remember. The reason for flickering is basically this, if you... Yeah, now that I think about it. If I run the executable and we look at the task manager, we're not going to change our password. We want to look at the task manager. And then we have a main function. You can see it eats up one of my cores because it's basically doing nothing, but it renders all the time. So it renders yeah, just a gigantic amount of frames per second. Well, gigantic's probably not because the GDI is pretty slow, but it basically permanently renders on top of itself all the time. So in order to avoid the flickering, actually what we can do is just sleep. Like for 8 milliseconds maybe. Sleep is just a basic Windows function also. And then, oh yeah, you see, this is what I did. So yeah, I guess that kind of helps with the flickering. It's still some flickering because I just basically randomly, without looking for when the GDI would display the window. I don't even think that there is a mechanism for this in this interface to tell you to wait on sync or something. With an higher level rendering, I mean with a modern rendering environment, you can basically wait for vsync or stuff like that, and you have double buffering and all this stuff. But this is just to show how it would work. So yeah, I'm quite happy actually with this. One thing I wanted to show, which I forgot, which I also will add, in our build system. You remember we added the user lib32 here right there in the build. But I personally like adding these things into the source file if they are depending on some operating system or anything else. So basically, with Visual Studio, you can use pragma, I think it's comment, lib, and then you add the library name. This works well with libraries that are part of Visual of the Microsoft SDK or stuff like that. But if you have libraries that are located somewhere else, you still have to tell the linker where to find those. But other than that, we can reduce this line even further, like so. And now all the information for the Windows platform is basically located in one file. And I personally like this a lot because you don't have to reassemble everything in your head. Everything is one place, and yeah, I prefer that. So what file user? Yeah, it's called user32lib. True enough. The pragma does not want a semicolon, we can accept that too, and we should be in feature parity, yeah. So, also another thing to consider, that's something we can also do if you, oh yeah, you have questions. And my own editor is using OpenGL. Yeah, it's just OpenGL. Basically, I have glyphs. I have a glyph atlas, so I load a file just like you do. And then I render portions of that file as little rectangles with some UV coordinates into the atlas, just like anybody else probably does. Yeah, it's single buffered, right? But also it just renders randomly, so it could display this while it could change it while it's being displayed or something like this. So should I try to implement navigation with arrows, or do you think that's good enough for now? Well, I guess then we get into the Q&A session, so you can ask me whatever. You're up for more. Navigation, okay. 2 votes on navigation. Well, since MTX wanted me to do this, I'm gonna try it. But it's not gonna be pretty. So, first of all, let's kill this. Oh! Now, okay, we have another thing to do because this is a common mistake and I don't want to leave people alone with this. So basically, if you have this window, right, I just closed it, the application is still running. It's a no-no. We don't want that. We want the application to be closed when the one window is closed, or if you have multiple windows, if all of them are closed, or whatever you want to implement. And in order to do that, we have to specify our own window callback. We right now are just using the default one, and we want to override the behavior. So somewhere in all these tabs, I had the callback, right? Yeah. So we're gonna implement our own, and so that our application will shut down properly, like everybody else would expect. So I'm just gonna call this Win32 window callback. And the callback part is just a hint, as is the in part. So on and so forth. And what we want to do basically is also do a switch on the message we have. So by the way, these parameters here basically are just what the message here already has in it. So if we look at peak message and we look at message struct, you will find these parameters. Like here they're spelled out properly, but as part of the standard signature, they are spelled horribly. But we can change the spelling however we want, as long as the types are correct. Like so, for instance. I would do it like so, but you know, it's up to you. Maybe I'm a little too pedantic on this part, but I like having more clearer names. So we would switch on the message, which is the same as we did here with switching on MSG message. Only that this is a callback, so this happens whenever Windows decides that it happens. And before we do anything, we can always return the default response, which is by calling the def window proc or def window proc A and returning whatever it would have done. And so we just pass the parameters through if we're not certain what to do. And only on things that we're interested about, we want to do something like, for our case, we want to react on the VM destroy message, which is called whenever a window is destroyed. And what we want to do is tell the application to shut down completely. And in order to do that, we can post a quit message and give it a return value, for instance. This can be in any arbitrary value. But all it does is basically it registers another message into the window in the message queue, which can be then retrieved with peak message. Also, as I mentioned, this callback can be called from Windows whenever it wants, but it also is going to be called whenever we call dispatch message. So we do that for every message, but some of the messages can be pulled and reacted to directly. Some of the messages will only be called directly with the callback. So yeah, we cannot really intercept them with a peak message call. So now that we get now that we posted the quit message, we can now react to it with by checking for the VM quit. And all we need to do is basically set our do continue to false so that we break out of the outer loop. And this should properly close the application. In order to verify that, we can call printf and say something like, we are done here. And if this message does not come, then we know we are either in an infinite loop or we have aborted somehow differently. So now we have this, and then if you press the close button, it still doesn't do it. Whoa. Oh yeah. The thing is, I only have implemented the message, but I have never used it. So we have still to tell the register class to use this new method, this new function instead of the previous one. So, and now if we close the window, it probably closes the application, which is an important part. Otherwise, you would call this application and it will be still running in the background, which is maybe not the desired behavior. Also, if you press Alt F4, it will also Alt F4 by default will I think destroy a window. And if you wanted to prevent that, you kind of have to catch it here, and then don't do translate message, because translate message is responsible for handling messages and convert them to other messages, like for instance reacting on Alt F4. Well, okay, this is the thing that I wanted to do, but you guys also want to do navigations, right? So I'm going to try this. So first thing to note, first thing to note, if we compile and run, if we use the arrow keys, we get no char messages, right? So maybe I did something wrong, but no, we print all the char messages. So the arrow keys on themselves, they do not produce characters because they're basically just for navigation and not for text editing in that sense. So, but all other keys will produce character messages. So now the thing is, we will still want to add them as though they were characters, so that we can react to them in order. So all these things will be added in order in Windows. So if we want to type something and somebody is so quick that he can also use the arrow keys at the same time, it might be a good idea to store all of those things in one contiguous array, like so, where the order on which the characters were put in also matters for editing. Other than that, if you kind of think that it's not important to you, you can also always just check if one of those keys was held down at the beginning of the frame, like you would do when you collect input for moving your character in the game or stuff like this. And that way, the only thing you know would be whether or not it was pressed that frame, not in which order. But we want to include it in the order as well. In order to do so, we have to go to the WM key message, which is responsible for collecting actual hardware keys on the keyboard, not their interpretation as a character. And if you look at that, we can C key down is what it's called exactly. So then we can see, wow, nice formatting there, Windows. Oh yeah, of course, everybody wants that. Hey. So then we can see here bits 16 to 23 are the scan code. Oh no, this is enough. So we have the virtual character code. Yeah, this is German, so I apologize. But basically, you get virtual key codes, which represent a physical key on your keyboard and also on a mouse. So if we use the W param, like so, message W param. Also, yeah, now that we will be using this this function multiple times, it might also be a good idea to make it into a function, like we did with the append function. So void, I'm just gonna call it push char, whatever. And it wants the characters, it wants count, character count, and it wants a max character count. So first thing we do is check if our character count is smaller than the max character count. If so, then we can note that this is a pointer because we want to change its value. So that's why I have to dereference it here. And here I want to also increment it, and here is just characters. And yeah, then, oh, no, of course, we also want to supply a code, like so. And then we can use this function on wchar and say, hey, whenever we get wchar, we just use platform characters, and we use platform character count as pointer because we want to be able to change it. And then we have oops. Oh my god. See, this is also a thing that I don't support. Like if I have wrapping lines and I want to go down, it will go to the next line instead of going to the wrapped line. So yeah. For anybody who envies my awesome text editor, it has so many flaws, you wouldn't even know. So this is how the code was previously, and now we want to use it also on some special keys, maybe. Like maybe we don't want to add all the keys as characters, only some select few. So we can use vk left, for instance, and the value we want to give into it should be some value which is not a proper character, so it should be less than space, for instance. In order to do that properly, we can have an enum, or we can, we can have a bool here and say is character. Otherwise, it would be a control character, for instance. And then we can also specify here bool is character and set just a nice way to distinguish control characters from actual displayable characters, like so. So yeah. And then when we call the function here, we can also now since we have this ability, we can actually just push the character, whatever it is, and just tell it that it's not a character. And here we tell it that it's always a character. So, and let's just compile this first. Google this character. Did I do something stupid? What is the meaning? Oh yeah, because this in our code this is a 32-bit number that we pass there because we don't need it to be any higher. It's your decision actually. So illegal case? Come on, people. It's not illegal. It's harsh. See how many error messages it spat at me just because I had too many braces. This is totally useless. It's completely useless information. Yeah, so that's why basically these error messages is why learning C++ is hard, because these just generally suck. You can, most of the time you can ignore anything but the first error messages, and this only vaguely hints you at the right direction. So yeah, thank you Windows. So, and now in our character code, we want to make sure that we handle this stuff should all just be character stuff. Like if you say if character is character, we do this switch. Otherwise, we want to handle control characters differently and just see if we still have the same abilities as before. Hello world. We can delete. We can add new lines. So this works so far, and now if we press the arrow keys, we get character informations like this. And as you can see, the arrow keys kind of produce valid characters like the ampersand or open parent. And if we would just pass them as they were, we would, instead of trying to use them for navigation, we would try to print these characters or append them to the text. That's why I did the distinction there. Okay. Yeah, all kind of weird, lovely little characters. So now we can do the exact same thing, only now we have to know which, yeah. Since I stored the virtual key codes, here we can just use them, like case vk left, for instance, to do stuff. And for this we need to add a new concept, which is basically a cursor, which we didn't have before. Right now we only append and remove from the end, but now we need a cursor to tell us where we are in the text and how to yeah, where to append stuff and stuff. So now for that we need a cursor, text cursor, and that text cursor should be anywhere between 0 and the byte count of the text. And now we can manipulate that, and hopefully everything goes well. So famous last words. First thing we do is, right now if you use the append function, we might also want to insert the cursor. Like so, text cursor. And append no longer is the proper name for it anyways, but we're just gonna roll with it for now. So all we need to do is say, okay, at the text cursor, we want to insert stuff. So first of all, this still applies, but this is no longer true. The position where we put in the new character is actually where the text cursor is, so it would be here. But since it could be anywhere in between, we need to make space for this character, otherwise we would be overwriting a character that's in that location. For that, I'm just going to use memcopy and say whatever is at the current cursor position, it should be 1 to the right. So this is the destination, so the destination is 1 to the right in memory, and the source is, and the source is wherever the cursor is, and how much do we have to copy is basically however big the text is, minus where the cursor is located. And I always mess this kind of thing up, so let's just think about it for a second. Say it was at position 0, then how much would I have to copy? I would have to copy all the things. Yeah, so yeah, that should make sense. Other than that, we also need to increment the text count. So now this is no longer an append, it's an insert, and I can rename these. Not that I have too many of these, but you know. And now our inserts should also consider our cursor. So that's the first thing that you have to do. And let's just see if this still works. Oh, also the deletion part is also something that we should consider. So you might want to write a new function called delete or remove at the cursor, and we want to, just how much we want to delete is probably just, it can be arbitrary, but I'm just going to say, also it makes sense if our character count is unsigned size, our cursor should be 2. So like so. And we can just tell it how many bytes to delete, basically. And first things first, we want to know if there is anything to delete at all. Basically, if our text count, let's see, if text cursor plus count is less or equal text count, then it should be valid. This is something I would use assertions for, but right now I'm not going to do it. So basically all we need to do is check if we have something to delete at all. Where does this count come from? Oh yeah, it's this count. Yeah, this is called a delete count because count might be a little bit confusing. So first things first is we want to do another memcopy, because deleting essentially is just moving text, basically removing a gap instead of creating a gap as an insert function. Where to remove the gap is basically, again, the position of the text cursor. And it's kind of up to us, but typically we want to delete the thing before our cursor. Like, yeah, that makes sense. So it should be -1, which also suggests that our text cursor is greater than 0. So something like this. Yeah. So we want to delete before the cursor, so it should be, yeah, not even that, but it should be greater than or equal to delete count. Otherwise we cannot delete this many characters. So at that position we will copy everything wherever the cursor starts, and now we have to figure out how much we need to copy. And this would be whatever the text, it should be the same if I'm not completely wrong, but you know, this is stuff that you have to kind of pay more closely attention to, because I'm just I'm just doing it live and I'm not really thinking about the indices properly right now. Where is the code? Delete, error, syntax error, delete. Oh, you don't like the word delete, huh? Yeah, it's the word is kind of a keyword for C++, I guess. So you cannot use it, even though it's a normal word that you probably want to use all the time. What is your problem? 52? Yeah. So our text cursor now needs to be a different size. That's fine. Okay, everything should work. Let's see. Probably not gonna work. Ah, yeah, you see? It's not working. Everything is being inserted at the beginning. Not at the proper position. So. Okay. Yeah. I honestly would love to stop right now because I'm getting kind of really sweaty. But I know this is a bit of a disappointing state to stop, so I'm just gonna look at the problem first. The other thing is that I cannot visualize the cursor right now, so that's a problem. Oh, I never incremented the cursor. Yeah, that of course is a no-no. You should increment your cursor if you insert stuff. And you should also decrement your cursor if you remove stuff. Yeah, small little things like this. Indexing is one of the hardest problems in programming, to keep track of all this little math stuff, I would say. Hello world. Hey, here we are. Oop. Yeah, you saw the application just crash because I probably accessed memory that I shouldn't have. So there is still a problem there. Hello world. Yeah, I cannot write back at that position, so it doesn't like the fact that our cursor. Oh yeah, because our insert does not consider the text cursor at all currently. But it shouldn't, I think. Oh, maybe sometimes right now here, if our text cursor is basically at the end, then we don't have to copy anything at all. So basically, if our text cursor is less than the text count, then we do the copy. Otherwise, we don't have to do anything. Then we insert this. Then we increase the count. Yeah, let's see. Kappa kappa. Ooh, okay. So appending and deleting at the end is restored, so that's a good thing. So okay, that's great news actually. And now the movement part would just be basically if we go into our is not a character code, we have to react to the VK left message, and it's basically very simple. If our text cursor is bigger than 0, then we can just reduce it. And the right message would be if our text cursor is less than our text count, then we can increase it. Basically, we are not allowed to be our text cursor should always be an index between 0 and including text count. So how many of you are willing to bet that this worked? Hello world. Now go 1, 2, 3, 4, 5. Stupid. I would say that worked. Of course, right now I have to imagine where the cursor is. But it works, so that's cool. how are you? Oh, it's a bit broken. So, oh yeah, I think the new line does not react to it properly. It should though. So I'm not quite sure. So basically, but this is all you have to do then. You just have to tell where the cursor is positioned. And if you have a selection, you have to keep track of two such positions as a range. And then you have to then you have to basically consider all the cases and how you want to manipulate the text selection and stuff like this. I guess the cursor is just a capital I being a different color. No, right now it's nothing because this interface, draw text and stuff like this, is just horrible to use it with. If you had your own interface, it would be easier to just figure out where the cursor is placed. And right now, I have no information available on how far because different characters basically have different widths or can have different widths. Your text rendering API needs to handle the fact that you want to know where something is positioned so that you can do fancier stuff with it. And this is of course the case with STB TrueType, like what Cakes uses, but also with FreeType. You can get all this information and then position your stuff accordingly. This API, however, it does have functions available to that, but it's not the point of this tutorial. So honestly, I think we are good. It's just to give you the basic concept. Other than these main two things, you also might want to consider doing like pref or next, prior and next, which are basically the up and down key. Or you want to use home. Yeah, I guess you want to use VK home, which is the begin and the end key, and you can use those to place the cursor basically at the beginning of the text. And this should always be possible to just say cursor 0. Or if you use VK end, I think. You just always say cursor is text count. And that would be a very simple way to navigate to the back and the front of your text. Like hello world, and then you press +1 and do something else. Y hello, and then go to the end again and type there, and go to the beginning again. You see, it's not rocket science. You just have to know where to find this information, basically, and I hope this tutorial helped you with that. I think I am very happy with what I did in 1 hour, 2 hours almost. Yeah, 2 hours with 50 minutes of waiting time. And I would now go into the Q&A and basically answer all the questions that you might have, but I'm going to stop implementing for now. We might do another one if you want to get into more detail on other aspects, but I have covered everything besides show cursor. So yeah. Okay, chat, it's up to you now. So, what did I miss? Is there a better way? Like, first of all, it's not that expensive. Like my files are like, let's say 5K at most, and it's quite. It's not too much work to basically copy 5,000 bytes or something. But if you have files that are hundred thousands of lines, it gets noticeably slow. And then you might want to think of another strategy, like you store per lines. You store things on a per line basis, and then you only have to copy the lines or stuff like that. So it's really up to you and up to your problem. Yeah, it's not that expensive, honestly. This is also a debug build of my editor because it keeps on crashing, and I want to know why. But I haven't gone around to fixing it. In the release mode, I can handle a file like the Bible, which is like 300,000 lines of code, and I'd use that for testing, and it's quite fast. Even if you copy it like several times behind it, and only like after 10 copies, like reaching a million lines, it gets really slow to edit things. So you should just try this out, and if it's good enough for you, I would stick with the mem copy. By the way, Cakes, do you want to stream afterwards? Will I add cursor? And I can make another tutorial if you guys want another tutorial. And I can do whatever you want to look at. And I also can release the code if you like. Normally also I would have added a lot of asserts, but I didn't want to implement assert here, and it's not that big, but it's to make it useful, you have to kind of yeah, you kind of have to clean it up a little bit. So if you don't want to implement an useless assert, you have to take your time. I want to get the YouTube video for the triangle out. Oh yeah. Yeah, push toy. It's just 100 more 2 hours of these, and you have your own engine. It's not too big of a deal. What is this, like 2 months of work? I need a full tutorial with autocomplete and stuff. There are so many steps between this and having autocomplete. It's not that easy, like seriously. There are a lot of things that you might want to consider, and I iterated over this editor like 3 times and changed a lot to make the input just usable. You're ready. Well, maybe I will do more of these, but not every day, but maybe once a week. Well, autocomplete depends on what information you have available. Like if you want autocompletion for a language like C++, you basically have to parse this language in some sense so that you can give useful information on what to autocomplete. But if you don't have that, you could basically tokenize all your text buffers and look for connected words. Like typically you would have words in a language like the normal C identifiers that are not really hard to parse. You have some things starting with a letter and then some arbitrary amount of letters and numbers that can change, and then you can kind of keep a list of that, and every time your user hits autocomplete, you will go through that list and compare it to the best fit and suggest that to the user. That would be a way to do this. You have to read in files because it's a text editor, so it's the whole point of it is to read files and to write them right. I mean, you're an expert on text files, Cake, so you should know about that. You can probably use whatever autocomplete library you want and hook this up to this. Yeah. Wow, well, I'm not gonna say that text files are binary, but actually they are. Like UTF-8 encoding, for instance, has a different byte count per character, so it's not just plain text. If you were to display it with with just Notepad or something. So yeah, how much more binary do you want to get? Do I have to read in the Vulkan Age to get Vulkan autocomplete? Well, the idea is basically, it depends on how you would do it, but the idea is basically that you would have whatever files are open, those files are the things that your editor could try to do autocompletion for. But if you have a more complicated environment, you should then have some mechanisms to tell your editor at what files to look at for autocompletion, so it's up to you. What do you mean 256 char option? I right now print less than 100 chars. UTF-8 has tries to encode 32 bits of UTF-32 code points into 124 bytes per character. I think it's only 24 bits, but the idea is that all human language and all human glyphs can be represented in one unified format. So there's a little bit more than 256 characters. Does anyone have questions to the code? We can go over some portions of the code that I might have skimmed over too quickly, but as long as you have questions, I'm happy to answer them. Yeah, the thing is you don't have to make a full editor. You can use this as a text edit field in your game, for instance. You don't have to make it a full editor, but maybe your game requires you to name things, or you can name your save file or whatever, or name your character. That's very common. This is how you can do it. Yeah, thank you, MTX. I need another water fill up. Be right back. So what else? What do you mean? I made a macro for array count, but not for assert, because you don't want to use BS. I do not see how this is connected. I use a macro for array count because it's trivial to implement, and there is no real standard for that. And assert, the only reason why I didn't implement assert is because it's a little bit of macro magic hassle. But other than that, I fully recommend asserting all over the place to whatever little assumptions you might have while writing the code, so that when it later violates those assumptions, you will be notified and can change and fix it, instead of being surprised when something just suddenly breaks. Crash won't yet. Crash will show if you implement your assertions like with the printf. You can, in this way, it will just print. Other than that, you can always pop up message box. So it doesn't matter if you're in debug mode or not, if you're running a debugger or not, it will still assert. It does matter, however, if you choose to only assert in debug builds. What does that mean? Where is Yapcock? What?
I don't know, email.
Oh, it's an emote that I'm missing, I guess. I'm for sure. Yeah, okay, that's good to know. I will keep it in mind. I mean, you convinced me to do this one, and a lot of people showed up, so that was really nice of you. So yeah, I probably will do another one, maybe on this topic or on another topic, whatever you might be interested in. So what's your plan, Cakes? Do you want to stream again tonight? You said you want to do the video editing. Seems like there are no further questions. Okay. Well then, I guess that's it for now. Thank you all for sticking around. Window color. What do you want with window color? Pushdoy, the rendering part of this tutorial is just placeholder. So I'm not gonna try to teach you how to use GDI because that sucks. If you want to know how to do rendering, you should ask Cakes since he did all this Wacom stuff. But I hope you could see how easy it is to actually get something going in Windows when you don't rely on other libraries. Because GLWF, or what's called, is still not going to handle the rendering for you. It's just going to handle the setup of the window and maybe some input-output. Okay then, thank you all for sticking around. You can always talk to me on Discord, and I will be lurking around in Cake's chats all the time. So you might notice that I'm a little bit too dominant in the chats. So yeah, feel free to ask me if you. I will think of a way how to upload this code if anyone cares. Other than that, I think we covered everything, so you should be able to look into the WOD. Yeah. Thank you all. I'm gonna go off for now. Thank you all very much, and see you tomorrow, I guess, in Cake's chat. Bye. Just have to find